Hello guys, so today I want to show you how to solve one of the easy graph theory problems that you can stumble upon, and of course we'll try to make it as cool as possible. And let's start with our project. Okay, enable hackerman mode, foreground color green. Okay, and let's copy out the text. So for a given list of connected points and a starting point, print out the road from the starting point, and here is the sample. So starting point is A, and these are the 5 connections between the points. So let me open up Microsoft Paint. Okay, so these are all the nodes A, D, C, M, D, B. Okay, this is B and X, and let's connect these like shown here. So A is connected to D, C is connected to M, okay, D is connected to C, B is connected to X, and M is connected to B. And our solution is A to D, C, M, B, and X. That is it. As simple as that. And there are 2 extra tasks we'll do as well. For example, when given a number, we want to skip a part of the road from the start, and we want to reverse the road. That's an extra 2 tasks. So let's first start off with inputs. So for example, var starting node equals console dot. Let's reverse this, so like this. Okay, console dot readline, and var edges, let's call it, or roads, equals console dot readline, but let's int dot parse it, and of course let's remove the warning by doing this. And now for loop for the number of roads, let's just console readline. Okay, instead of roads, let's roads number, and this is roads, new list of string, and let's just roads that add console readline, something like this. No, just like that. Okay, and let's test it out that our input is correct. Okay, so we want a console WriteLine starting node, console WriteLine roads number, and console WriteLine string that join with the separator like this, maybe, and the roads. Okay, simple as that. And we need this input, so let's copy it out somewhere and make it clean. And our input is starting node A, 5 connections, and let's go with that. Okay, So I'm sorry, like this, and you press enter. Okay, there's A as a starting point, 5 connections, and these are the connections. Okay, so our input is correct. So how I wanna solve this? I wanna solve this with a simple solution. Let's just use the simple linked list. Okay, and what a linked list is, I'll show you. Let's add a class called node, make it public, and that class has another node in itself called next. And so, and let's give it a name as well, public string ID, let's say. What this means is let me show you. So it means our class node can have a child that is also a node. That node is also a node, so it can also have a child that is a node. And since it's nullable, we said it's nullable, the last one can have no connection, so a null. Okay? And that is exactly, when you look at it, that is exactly what we need here to get this graph going. And we want to make it cool, so since we are parsing the integers like this, we want to parse the nodes as well. So let's make a public static node parse, and we will parse the string ID, and we will have a collection of nodes so that the node with the same ID when parsed is never repeated. So we will have a private static read-only hash set of node, which is nodes, and just do it like this. And if we can, we will do something like this. Sorry. If you remember in the first video that we did, there is graph theory. I think in graph theory we actually did this already for the node. So yeah, we need something exactly like this. So what we will do is we will create a new node. So var node equals new node and ID equals ID. Okay, but we will try and see if these nodes that add, if it's a newly added node, then we will just return it. Otherwise, if you can see this method here, true if the element is added, false if it is already present. Otherwise, we will return just existing one in the collection of the nodes. First, where x.id equals node.id. Okay, and we need to hash them out so that they are the same. For a hash set, we want ID to be our hashing function. Okay, and we wanna make them equal by the ID as well. So this, using these two methods, you control the hashset.add method. So it will use these two methods to compare the items, to check if it's actually the same item. So we can have a different new node with the ID, but hashset will only allow you to give to put in the ones with the same ID once, if we do it like this here. Okay, and let's call this hashset stuff, and let's close it out. Okay, and now in our program, instead of starting node, let's call this node dot parse. Okay, and now for these connections, we know that there are, so all the nodes will be in these connections here. So we cannot know if this first one will start connecting to the next one. It's mixed up, right? So, but we can still collect all the nodes by doing simply something like, okay, var road equals console.readline, and then road.split, when you split it by road points, when you split it by the separator, we will get both points, both nodes, and then we will just node parse road points of 0 and node parse points of 1. By doing this, we collected all the nodes, and we could try to test this out. We could go and put a breakpoint here, for example, and let's expose this by doing public static hash set nodes, and expose this nodes just for the test to see what our nodes are. Node.nodes. Okay. And to make it easier to see in our debugger, we will also override the string, and we will return ID. So this will be shown in our debugger when we mouse over. Okay, see, simple as that. Okay, connecting points, and let's take our sample. Okay, and let's see here in the nodes collection, we have how many? 6 nodes: A, D, C, M, B, and X. That's correct. Okay, so there is that, and now we also need to build connections with these nodes, and since we already have them here, we can do it like this. So var node 1 equals var node 2 equals, instead let's just do it like this. Okay, then we can do node 1 dot next equals node 2, and by doing this, I'm pretty sure we already solved the problem. Okay, so now we got every road connected, every 2 nodes, and let's check it out. So from starting node dot next dot next dot next dot next, we can have a full solution here. So let's try to do something like that. While starting node, let's do while we'll figure out the next one later. Console write line node.id, and let's actually put it like this. Node, we know that the string will return id, and space between. Okay, and node equals node.next, and do this while node is not null. Let's test it out on our sample. I'm sorry, I caught that part there. Let's go. Okay, so our road is ADCM. Okay, so not right line but right. Let's see. ADCMBXA and 5. Oh, let's remove the test. ADCMBX, is that the solution? I'm pretty sure it is. ADC, MB and X. But I don't like this. Let's see how much we are. 16 minutes in. We have some time, so let's try to make this cool by doing this, by making it so that we can do something like starting dot enumerate or something like that. So let's make it enumerable, so that we can just say node dot, or like for each var item in starting node, something like this. You'll see why. Okay, and to do so, let's make it enumerable of node and implement the interface. And how can we return all the nodes in order? Well, we already have the code here, so let's do public or private actually. Enumerable of node, get nodes, and starting node is this, and let's yield return it, and yield return every next node as well. And let's put it in a different order, not like this, but while it's not null, you'll return it, and next, and node equals node.next. Okay, so this way we should be able to just use something like this: var node in starting node, and just console write line or console write node. And let's see, where is our sample? Okay, we did not actually return that here. Okay, so return get nodes. Okay, let's go get connected, get full list. full linked list. Okay, and dot get enumerator. And I'm pretty sure we can copy paste this out here and it will convert it properly to enumerator. Yes. Okay, let's try again. So the code is this now. Come on, copy, paste, ADC MBX, and that is it. That's exactly what we want. Or we can just do like console write line string that join with a separator and starting node without a for each. Okay. Oh, come on. Okay. ADC MBX, that's true. Okay, let's put it in result. Okay, and let's say so how do we do the extra two? Well, it's super simple. Now you can apply link queries. So to skip 2 we will just do dot skip 2, and let's see. CMBX, that is expected. Here CMBX. Okay, how do we reverse it? Well, we just do dot reverse. Okay, and the output needs to be this one, XBM CDA. That's it. So basically what we did here, super simple. We just parsed the nodes, we connected them together. Maybe this part is unclear to someone. So this is these two methods are used for hash set for its equality comparer. So when you are hashing things, so I don't want to go too much into detail, but these two methods are called for hashing. So basically when some item is trying to be added to the hash set, its hash code is calculated to find the bucket in the hash where it needs to drop the item, and with equals it checks if the item is already there and stuff like that. Not exactly that, but you can, if you are really interested, you can go to find the open source of .NET implementation of hash set and stuff like that, or some simpler set. And this here, as you can see, we just yield return is a method used when you have a enumerable. You can just return items one by one during while running the method. And with a code simple as this, we just yield return next node, and while that node is not null, and that way we get the enumerable for our nodes. We could just copy this out here. I'm pretty sure it would work like this. Okay, and then just use something like this. I think this would work. Let's try that out with our sample. Yeah, XBMCDA. Yeah, that's the reversed one. And let's get it back to the original one so I can post this code later on. Yes, that's it. Okay, so yeah, that's basically it. So thank you guys for watching, and see you next time, I guess. Bye bye.